Hi guys, today I'm going to introduce you comparison of the OSI and TCP IP reference models. Both models are based on concept of stack of independent protocols. The functionality of the layers is roughly similar. For example, in both models, transport layer and layers above it provides a end-to-end and network independent services. Again, in both models, the layers above the transport layer are application-oriented users of the transport service. The three concepts which are central to the OSI reference model are services, interfaces, and protocols. OSI model can distinguish them clearly. For, for example, each layer performs some services for the above layer above it. The service definition tells what the layer does, how entities above it accesses it, or how the layer works. It defines the layer semantics. Then interfaces. The interfaces tells the processes above it how to access it. It specifies what the parameters are and what results to expect. It says nothing about how the layer works inside. Finally, the protocols used in a layer are the layer's own business. To get the job done, it can use any protocol that provides the offered services. It can also change them without affecting software in higher layers. These ideas fit very nicely with modern ideas of programming. For example, object-oriented programming. An object has a set of methods, that is operations, that processes outside the object can invoke. The semantics of these methods defines the set of services that the object offers. The code internal to the object is its protocol and is not visible. It has not any concern outside the object. The TCP/IP reference model did not clearly distinguish between services, interfaces, and protocols. For example, the only real services offered by the internet layer are send IP packet and receive IP packet. The protocols in the OSI model are better hidden than in the TCP/IP reference model. They can be replaced relatively easily as the technology changes. The OSI reference model was devised before the corresponding protocols were invented. The model was not biased towards one particular set of protocols. That is, OSI reference model is quite general. The designers of OSI model did not have much experience with the subject and did not have a good idea of which functionality to put in which layer. For example, the data link layer originally dealt only with point-to-point networks. When broadcast networks came around, new sublayer, that is the MAC layer, has added to the model. Further, when people started to build real networks using a OSI model and existing protocols, it was discovered that these networks did not match the required service specifications. So convergence sublayer were added to the model. Finally, the committee originally expected that each country would have one network run by government and using the OSI protocols. So no thought was given to the internetworking. With TCP/IP, the reverse was true. The protocol came first and the model was really just a description of existing protocols. There was no problem with the protocols fitting the model. They fit perfectly. The only trouble was that the model did not fit any other protocol stacks. It was not useful for describing other non-TCP networks. The OSI model has 7 layers and TCP/IP model has 4 layers. Both have network, transport and application layer, but other layers are different. Other difference is in the area of connectionless service versus connection-oriented service. The OSI model supports both connectionless and connection-oriented services in the network layer. but only connection-oriented service in the transport layer. The TCP/IP model supports only one mode in the network layer, that is the connectionless service. But both services, that is connectionless as well as connection-oriented services, in transport layer and gives the user a choice. Choice is especially important for simple request response protocols. Then I will summarize the comparison. First, the OSI is a generic protocol, independent standard, acting as a communication gateway between the network and the end user. The TCP/IP model is based on standard protocols around which the internet was developed. It is a communication protocol which allows the connection to hosts over a network. In OSI model, the transport layer guarantees the delivery of packets. That is, it provides the connection-oriented service. In TCP/IP model, the transport layer does not guarantee delivery of the packets. Still, the TCP/IP model is more reliable because it supports both types of services, that is connection-oriented as well as connectionless services. Also, it takes the special services related to multimedia. Then, next is OSI reference model follows the vertical approach, while TCP/IP model follows the horizontal approach. OSI model has a separate presentation and session layer. TCP/IP model has not separate presentation and session layer. OSI model is the reference model around which the networks are built. Generally, it is used as a guidance tool. TCP/IP model is in a way implementation of OSI model. The network layer of OSI model provides both connection-oriented and connectionless service, while the network layer in TCP/IP model provides connectionless service. The OSI model has problem of fitting the protocols into the model. TCP/IP model does not fit any protocol. Next is protocols are hidden in OSI model and are easily replaced as the technology changes. In TCP/IP, replacing protocol is not easy. OSI model defines services, interfaces, and protocols very clearly and makes clear distinction between them. It is a protocol independent. In TCP/IP, services, interfaces, and protocols are not clearly separated. It is also protocol dependent. OSI reference model has 7 layers and TCP/IP reference model has 4 layers. Now I will introduce you concept of ports and sockets. First, we will consider ports. In the Internet protocol, the port is an endpoint of the communication link in an operating system. It is permanently related with the IP address of host. The service is recognized by the port number. TCP and UDP protocols use ports to map inward data to the individual processes on the computer. Then port number. The port number is a way to identify the specific processes to which the internet or other network message is to be forwarded. For transmission control protocol and the user datagram protocol, a port number is a 16-bit integer that is put in the header appended to the message unit. This port number is passed logically between client and server transport layers. For example, a request from a client to a server on the internet may request a file to serve from that hosts file transfer protocol, that is FTP process. In order to pass your request to the FTP process in the remote server, the transmission control protocol in your computer identifies the port number of 21 and it appends in request. At the receiver, the TCP layer will read the port number 21 and forward your request to the FTP program at the server. Some services or processes have conventionally assigned permanent port numbers. These are known as well-known port numbers. In other cases, a port number is assigned temporarily from the range of assigned port numbers. This is called as ephemeral port numbers. So the port numbers are allocated into three ranges. First one is the well-known ports starting from 0 to 103, 0 to 1023. These port numbers are assigned and controlled by IANA, that is Internet Assigned Numbers Authority. The next range is the registered ports. Starts from 10242 49151. These are not registered and controlled by IANA, but registered by, not assigned. These are not assigned and controlled by IANA, but registered by IANA. Next is dynamic and or private ports. Starts from number 49152 to 65535. These are not assigned and registered by IANA. The next is some ports have been kept to provision for shared service or well-known service. Then next we will see meaning of sockets. A network socket is a one endpoint. Socket address is the combination of an IP address and the port number. In networking, a socket is used to allow many processes within a single or different host to use TCP communication simultaneously. The socket is formed by including the IP address with the port number to uniquely identify each separate data stream. A connection can be fully specified by the socket at each end. We call socket as a type of a tag that individually identifies and keeps a connection. This connection is kept in such a way that request and apply are sent and received by the currently mapped application running on a device. Thus here socket address is the address of port number, that is the combination of IP address and the port number. Then types of sockets. There are two types of sockets, active sockets and passive sockets. Active socket is associated to a remote active socket through an open data connection. Closing the association terminates the active socket at the endpoint, at each point. Then passive socket, it is associated but awaits an incoming connection, which will or which is a new socket, a new active socket. Then for more clarity, let us take an example. Suppose, think our machine is a apartment building. That is, we will consider machine as an apartment. A port is an apartment number. Socket is a door of an apartment. An IP address is the street address of the building. Then the port and sockets help to identify process running on the host machine uniquely. When web page is terminated automatically, the socket programs will be terminated and associated port numbers are released back. Then I will summarize the difference between port and socket. Port is a number used by particular software. The same port may be used in different computers or servers running same software. While the socket is a combination of port and IP address to identify particular software and particular computer or server. Port is a logical data connection that can be used to exchange the data without the use of temporary file or storage. While socket is an endpoint of a bidirectional communication that occurs in computer network that is based on internet protocol. Ports operate at the transport layer of OSI, while the sockets are the means of plugging the application layer in. This port also operates at the transport layer of TCP/IP model. Port is a request running at the socket, and port uses socket to deliver the packet to correct application. I'll repeat here. Port is a request running on the socket, and the port uses the socket to deliver the packet to correct application. While the socket is the way a server and client keep track of requests. In port, next is a port functions like a telephone number, identifying the machine and giving the socket an area to connect. While the socket functions like a cord that ties a computers together. Then I will introduce you next point, that is encapsulation and decapsulation. One of the important concepts in protocol layering in the internet is encapsulation and decapsulation. Then we'll see how encapsulation takes place at the source host. At the source, we have only encapsulation. At the application layer, the data are exchanged is referred to as a message. A message normally does not contain any header or trailer in application layer. The message is passed to the transport layer. The transport layer takes the message as a payload and adds the transport layer header to the payload. The transport layer header contains the identifiers of the source and destination application programs that want to communicate. It also contains some more information that is needed for end-to-end delivery of the message. Such information is needed for flow control, error control, or congestion control. The result is the transport layer packet, which is called as the segment in TCP and the user datagram in UDP. The transport layer then passes the packet to the network layer, that is segment or datagram to the network layer. The network layer takes the transport layer segment or datagram as a data or payload and adds its own header to the payload. The header contains the addresses of source and destination host and some more information used for error checking of the header, fragmentation of the information, and so on. The result is the network layer packet called a datagram. The network layer then passes the datagram to the data link layer. The data link layer takes the network layer packet, that is the datagram, as a data or payload and adds its own header, which contains the link layer address of the host or the next hop. The result is the link layer packet, which is called as frame. Means here the segment is get converted into frame, and actually the frame is passed to the physical layer for transmission. Then decapsulation and encapsulation at the router. At the router, we have both decapsulation and encapsulation because the router is connected to two or more links. After the set of bits are delivered to the data link layer in router, this layer decapsulates the datagram from the frame and passes it to the network layer. The network layer only inspects the source and destination addresses in the datagram header and consults its forwarding table to find the next hop to which the datagram is to be delivered. The contents of the datagram should not be changed by the network layer in the router unless there is a need to fragment the datagram if it is too big to be passed through the next link. The datagram is then passed to the data link layer of the next link. The data link layer of the next link encapsulates the datagram in the frame and passes it to the physical layer for transmission. Then decapsulation at the destination host. At the destination host, each layer only decapsulates the packet received, removes the header, and delivers the payload to the next higher layer protocol. In this way, the message finally reaches to the application layer. It is necessary to say that decapsulation in the host involves error checking. So, in this way, I tried to introduce you most of the points related to comparison of OSI and TCP/IP reference model, meaning of the ports, meaning of the socket, and how encapsulation and decapsulation takes place in data communication through the internet.